Mercury, the very first planet of our solar system. It's so close to the sun that it's bathed in blinding light every single day. And yet, this tiny world remains the least explored of all the rocky planets. Is it just a boring, airless rock? Or is there something far more dramatic hiding in plain sight? The truth is, Mercury is one of the most extreme places you could ever imagine. A place where a single day lasts twice as long as its year, where temperatures swing from extreme heat to freezing cold in a single rotation, and where the ground itself has been slowly shrinking for billions of years. And reaching this mysterious world was one of humanity's most daring space achievements, a journey spanning billions of kilometers and taking more than 6 years to complete. Today, we'll uncover Mercury's secrets, its bizarre orbit, its violent volcanic past, and the mission that changed everything we thought we knew about this small planet. So buckle up, we're going closer to the sun than ever before. Hello and welcome. I'm Orion, coming to you from Infinite Universe NTH. Mercury is the smallest planet in our solar system, barely bigger than our own moon. Yet it's made of mostly metal, giving it one of the highest densities of any planet. Its name comes from the Roman messenger god, Mercury, the swift one, and that name is perfect. This little world races around the sun faster than any other planet, completing an entire orbit in just 88 Earth days. That means if you lived there, you'd celebrate a birthday every 3 months. And the view from Mercury is stunning. The sun appears more than twice as large as it does from Earth, a brilliant blazing disk hanging in the sky, with no thick atmosphere to soften the light. Every sunrise would be breathtakingly sharp, every shadow pitch black. But don't let its speed and size fool you. This is a planet with a surprisingly complicated story, a world of ancient lava seas, giant craters, and bizarre geological scars that scientists are still trying to understand. When most people picture Mercury, they imagine a dull gray ball, a smaller, hotter version of our moon. But take a closer look, and you'll see that Mercury is much more than that. This little world is made of about 70% metal and 30% silicate rock, which makes it more metallic than any other planet in the solar system. That composition gives Mercury a density of 5.4 grams per cubic centimeter. In fact, if Mercury were the same size as Earth, its surface gravity would be almost the same. Because it's smaller, its gravity is only about 38% of Earth's, just slightly stronger than Mars. If you could stand there, you'd feel lighter, but not floating like on the moon. And here's something fascinating. 2 of the solar system's largest moons, Ganymede and Titan, are actually bigger than Mercury. But they are made of lighter material, so Mercury still outweighs them. Look at its surface in true color. It's not just shades of gray. Mercury has subtle browns, creams, and yellows. Across this surface are scars from billions of years of impacts, vast plains, countless craters, and narrow cliffs called scarps that stretch for hundreds of kilometers. These scarps are evidence that Mercury has been shrinking as it cools. Its entire diameter has contracted by more than 14 kilometers since its birth. And then there's Mercury's crown jewel, the Caloris Basin. This colossal impact crater is 1,550 kilometers across, one of the largest in the solar system. The strike that formed it was so powerful that it left towering rings more than 2 kilometers high and even warped the terrain on the opposite side of the planet. All of this tells us something important. Mercury may look quiet today, but its past was anything but peaceful. Standing on Mercury would be like visiting 2 completely different planets, depending on which side you're on. With no thick atmosphere to trap heat, Mercury's surface experiences some of the most extreme temperature swings in the solar system. When the sun is overhead, the ground bakes at more than 400 degrees, hot enough to melt lead. But just a short distance away on the night side, temperatures plunge to 170 degrees, colder than a polar winter on Earth. Near the poles, where the sun never climbs high above the horizon, it never gets warmer than 90 degrees C. Those shadowed craters stay so cold that water ice can survive there for billions of years. A surprising oasis on this planet. Mercury can't hold on to a thick atmosphere the way Earth or even Mars can. Instead, it has a whisper-thin exosphere, so thin that the molecules almost never collide with each other. Yet, this fragile layer still tells a story. When the solar wind slams into Mercury, it strips atoms away, creating a long comet-like tail streaming behind the planet. Under the right instruments, Mercury looks as though it's glowing and leaving a faint yellow trail across space. This mix of extreme heat, deep cold, and a disappearing atmosphere makes Mercury one of the harshest environments in the solar system, and one of the most fascinating. As if Mercury's extremes weren't enough, its day and night cycle is one of the strangest in the entire solar system. Mercury races around the sun faster than any other planet, just 88 Earth days for a full orbit. But it rotates on its axis only once every 59 Earth days. This creates what scientists call a 3-to-2 spin-orbit resonance. Mercury spins 3 times for every 2 orbits around the sun. Here's what that means if you were standing on the surface. From one sunrise to the next, what we call a solar day, you would wait the length of 2 Mercury years. That's right, a single day on Mercury is twice as long as its year. And it gets even stranger. As Mercury approaches its closest point to the sun, perihelion, its orbital speed actually matches its rotation for a short time. To an observer on the surface, the sun would appear to pause in the sky, slowly drift backward, and then resume its normal path toward sunset. Imagine standing there, watching the sun reverse direction, like a cosmic trick of time. It's one of the most surreal natural spectacles in the solar system. For centuries, astronomers thought Mercury was tidally locked, always showing the same face to the sun, just like the moon does to Earth. If that were true, one side would be in endless daylight while the other stayed in eternal darkness. But thermal measurements didn't match that idea. The night side was warmer than it should have been. The mystery was solved in the 1960s when astronomers used radar to bounce signals off Mercury's surface. They discovered that Mercury does rotate, just very slowly. That single discovery completely reshaped our understanding of the planet's climate and history, revealing that Mercury's dance with the sun is far more complex and elegant than we ever imagined. But if this little world is so fascinating and so close to us, why did it take so long for us to visit? For most of human history, Mercury was just a distant point of light, too close to the sun to study for long. Even when we had the technology to send probes to other planets, Mercury remained frustratingly out of reach. At first glance, you might think getting to Mercury should be easy. After all, it's the closest planet to Earth on average. But here's the problem. When you launch a spacecraft toward Mercury, it falls toward the sun, speeding up dramatically under the sun's powerful gravity. Slowing it down enough to be captured into orbit would require enormous amounts of fuel, far more than a small scientific spacecraft could carry. For decades, this challenge kept Mercury out of reach. After the Mariner 10 mission's brief flybys in the 1970s, no one visited Mercury again for 30 years. Then came a breakthrough. In the 1980s, an orbital mechanics expert named Chenwan Yen worked out a clever solution. Instead of flying straight to Mercury, a probe could take a long, looping path around the solar system, using gravity assists from Earth, Venus, and even Mercury itself to gradually slow down. NASA took this idea and built Messenger, a compact, heat-shielded spacecraft designed to survive Mercury's furnace-like environment. Launched in 2004, it spent 6.5 years looping around the inner solar system. It flew past Earth once, Venus twice, and Mercury 3 times before finally slowing enough to enter orbit in 2011. But even then, the drama wasn't over. During its third Mercury flyby, Messenger suddenly went into safe mode, a protective shutdown meant to save the spacecraft from damage. For hours, mission controllers didn't know if the spacecraft would recover. Finally, as Messenger emerged from Mercury's shadow and recharged its batteries, its systems came back online. The mission was saved. When Messenger finally settled into orbit, it began a 4-year survey of the planet, far longer than the single-year scientists had planned. In the end, it took over 200,000 images, mapping Mercury in stunning detail. And when its fuel finally ran out in 2015, Messenger ended its mission by gently impacting the surface, leaving a tiny, invisible scar on the very world it had revealed to us. Messenger's success was one of NASA's quiet triumphs, a mission that rewrote everything we thought we knew about Mercury. And what it discovered was nothing short of astonishing. For the first time in history, we saw the entire planet in full color and high resolution. Mercury was no longer a blurry gray dot. It was a world with rich textures, subtle hues, and a violent past written across its surface. One of the biggest surprises came from its magnetic field. Mercury is the only other rocky planet besides Earth to have a global magnetic field, but Messenger revealed it's shifted off-center, about 20% closer to the North Pole. No one is quite sure why. The leading idea is that Mercury's large iron core is still partially molten, stirred by tidal forces as the planet's orbit stretches and squeezes under the sun's gravity. Then there was the discovery of water ice at Mercury's poles, locked inside craters that never see sunlight, billions of tons of frozen water sitting just beneath the surface in one of the hottest places in the solar system. Messenger also revealed that Mercury is shrinking. The planet's entire crust has contracted by more than 14 kilometers in diameter since its formation, leaving behind huge cliffs and ridges hundreds of kilometers long. It's as if the whole planet is slowly crumpling in on itself. And Mercury's surface turned out to be surprisingly rich in volatile elements like sodium, potassium, and chlorine, materials that should have boiled away if Mercury had formed so close to the Sun. Their presence has forced scientists to rethink how the entire solar system formed. Far from being a boring rock, Mercury was suddenly one of the most scientifically exciting places in the solar system. But perhaps the most dramatic revelations came when scientists looked closely at its craters and lava-filled plains, clues to a time when Mercury was literally on fire. Billions of years ago, Mercury was anything but quiet. Back then, the planet's interior was still blazing hot. Gigantic asteroid impacts punched through its crust, releasing magma from deep below. The result? Vast seas of lava spreading across the landscape, glowing like rivers of fire under a harsh young sun. Look at the Radit-Ladi Basin. Today, it's a smooth, dark plain, but scientists believe it was once a cauldron of molten rock. When the asteroid that created it struck, the crater quickly filled with lava, which hardened into the flat surface we see now. Messenger's cameras also revealed fine layers of volcanic ash coating some regions, evidence of explosive eruptions powerful enough to fling material high into the sky before it rained back down. NASA scientists nicknamed it fiery, hot, angry snow. And this wasn't just a local event. Similar signs of lava flows can be seen across Mercury, valleys filled with smooth rock, craters like Rachmaninoff, showing cracks where magma pushed up from below, cooled, and then cracked again as the planet's temperature swung between extremes. Some eruptions were so violent that they blasted entire cavities out of the surface, leaving behind strange craters with no central peaks. Formations carved not by impacts from space, but by explosions from within. Imagine standing there as the ground beneath you rumbled, magma burst forth, and glowing rivers of lava lit up the horizon. Mercury was once a truly hellish world, but over time, its fury subsided. The volcanoes eventually quieted. The crust settled and reshaped, and the Mercury we see today stands as a resilient world, carrying the marks of its powerful past. Yet even now, Mercury keeps some of its secrets hidden, puzzles that scientists are still trying to solve. Take Pantheon Fossae, a spider-like pattern of fractures radiating across the surface. At first glance, it looks like shattered glass, as if something beneath the crust pushed upward and cracked the ground in every direction. Near its center sits the crater Apollodorus, but strangely, the crater isn't perfectly aligned with the center of the fractures. Could this be a coincidence? Or is it a clue that the cracks formed first and the crater came later? We still don't know for sure. Were these features caused by a massive upwelling of magma that split the crust apart? Or could there be other forces at work beneath Mercury's surface that we haven't yet detected? Then there are Mercury's spectacular ray systems, bright lines of ejected material stretching for hundreds, even thousands of kilometers. Some, like the rays from the crater Hokusai, wrap nearly all the way around the planet. These remarkable impacts act like natural time capsules, helping scientists piece together Mercury's history and the dynamic environment of the early solar system. Each discovery opens new questions. And that's why Mercury is far from a finished story. Mercury's story didn't end with Messenger. Right now, a new mission, Bepi Colombo, is racing through space on its way to this mysterious world. Launched by the European Space Agency and JAXA, it's following a complex 7-year path of gravity assists around Earth, Venus, and Mercury itself. When it finally arrives in 2025 and 2026, Bepi Colombo will separate into 2 orbiters, one built to study Mercury's surface and another to probe its magnetic field and interior. Together, they'll give us our most detailed look yet at the smallest planet, and maybe solve some of the puzzles Messenger left behind. Mercury may be small, but it has a giant story to tell, one that connects to the history of our solar system, and maybe even the story of how Earth became a world where life could thrive. So stay curious, because the next few years could change everything we know about this tiny, resilient planet. Thank you for joining me on this journey. I'm Orion, and this is Infinite Universe NTH. If you enjoyed this adventure, don't forget to subscribe, so you won't miss the moment when Bepi Colombo finally reaches Mercury and writes the next chapter in this incredible story.